Differential calculus is our new topic that we are studying. Differential calculus. We will begin by looking at what we call limits. The concept of limits must be understood thoroughly. The concept of limits must be understood thoroughly so that as we go through this topic, things will be easy for you. Remember, we have been dealing with functions. If I have a function f of x, which is defined by x squared minus 4 all over 4x minus 8. Now, this function is undefined. It is undefined when the denominator, which is 4x minus 8, 4x minus 8 is equal to 0. Which means we can actually calculate the value of x for which this function f is not defined. So 4x is equal to 8, which means x is equal to 2. At a point x is equal to 2, this function is not defined. But we want to talk about the limit. Does it have a limit at that point? So we are going to look at a sketch of this graph quickly without even doing much of the explanation. This graph will show you that at some point 2, it is not defined. That's why I'm putting a circle on that line. It means at this point when x is 2, this function is not defined. It means there is no y value. But does it have a limit? That's the question. We can investigate if it has a limit by looking at numbers that are on the right approaching 2 and the numbers that are on the left approaching 2. If as we get close to 2, the values at this point and that point are almost the same, or they are exactly the same, then we can say the limit of this function when x approaches 2 exists. Very, very important. So if we want to do that, you will notice that we can draw a table and we select values that we substitute, and those values, as I said, must be to the left of 2 and to the right of 2. So if as we get closer to 2 from both sides, we approach the same number, then a limit exists at that point. Very, very important. So if we can now write the limit of x squared minus 4 over 4x minus 8 as x approaches 2. We don't care from which side. It might be from the left or from the right. It doesn't matter. The x value is approaching 2. Then using our factorization, which we all know, you factorize that. That is a difference between two squares. It will be x plus 2 into x minus 2 all over. There we have 4x, 4 into x minus 2. So the bracket will cancel out. So what we are remaining with is limit as x goes to 2 of x plus 2 all over 4. Our x is approaching 2, which means we can now say it's 2 plus 2 all over 4, which gives us 4 over 4, which is 1. Which means the limit of the function f as x approaches 2 is actually a 1. So it does exist. The limit does exist. Let us look at another illustration. Limit of 3 over x minus 2 as x approaches a 3. Yes, it does exist, because this means we have 3 over x is approaching 3, 3 minus 2, which gives us 3 over 1. So the limit is 3. Please take note of that as well. And then limit of x approaching a minus 4 of 5 over x plus 3. This again we are going to substitute. We shall have 5 over x is approaching minus 4 plus a 3. And this will give us 5 over minus 1, which is a minus 5. But now if we look at this one, limit of 3 over x minus 2 as x approaches a 2. The limit here does not exist. It does not exist. Why? Because if we substitute a 2, we will have 3 over 2 minus 2, which is 3 over 0. This is undefined. It is not defined. But we can also show this graphically. Remember, we have dealt with hyperbolic functions. So if our f of x is equal to 3 over x minus 2, if we are to sketch this, we all know we have the asymptote, which is what? X is equal to 2. So x is equal to 2 is an asymptote where this is 2. And we have y is equal to 0. Remember your grade 11 and grade 10 work where we did functions. We are simply saying the graph is going to have asymptotes. X is equal to 2 and y is equal to 0. Very, very important. Now, we can calculate the x-cut of this graph, y is equal to 0. So it will do this, it will say our 3 over x minus 2 is equal to 0. So 3 is equal to 0. Meaningless. These can never be equal. It means actually y equal to 0 is an asymptote. Then the y cut, our x is equal to 0. So we shall have 3 over 0 minus 2 is actually y. So our y is minus 3 over 2, which is minus 1.5. So it's right here. So our graph approaches the asymptote, cuts the y-axis, and approaches the other asymptote, and it will never cut the asymptote. And we have its twin sister in the vertically opposite quadrant of the asymptotes. So you can see, as we are approaching 2, this one is going to minus infinity, and this one is going to plus infinity. These are two different numbers. Therefore, we can conclude and say limit does not exist. Very, very important. So in short, let me now give you a definition. A function has a limit if it has almost identical values on either side of the undefined value. That is when we talk of a limit. A function has a limit if it has almost identical values on either side of the undefined value. And also a function does not have a limit if it has different values on either side of the undefined value. Thank you very much.